Okay, here we go with video 4.3, a discussion of skin cancer. We will look at some other skin pathologies here in a future video, but I wanted the skin cancer one to have its own video. As you can see from our list of topics here in this video, there are a number of issues related to skin cancer that are worthy of our understanding, including what about the sun causes cancer, the potential cancerous nature of moles, and what are some risk factors for developing skin cancer. And we'll also consider the question that a lot of people ask me about, are tanning beds safe or even safer? So let's start with this idea. The media wants us to celebrate the sun because they want to sell us suntan lotion and sunscreen, and they want us to be outside because they can sell us more stuff if we're out worshiping the sun. Miss Hawaiian Tropic and all the culture around tanning is certainly strong. However, and no one is really suggesting that you can't be outside safely. However, there are risks to being outside associated with the sun, and let's figure out why. When you look at the energy that comes from the sun, we normally associate that with heat and light. Those are the obvious forms of energy that we associate with the sun. But other forms of radiation are also coming from the sun as well, and including UV radiation. And if you notice here, we have different forms. We have UVA, UVB, and UVC. And the difference in these energies is in their wavelength. UVC, for example, is from 100 to 290. And this energy is not even going to penetrate our atmosphere because it's not strong enough to really do anything, and therefore not even a concern related to skin cancer. 290 to 320 represents UVB, and UVB actually is a form of energy because it's just strong enough to actually do some damage, and we will consider that in just a moment. UVA has even longer wavelengths that can penetrate deeper into the skin and can do some more damage, including damage to DNA. So when we consider wavelengths of energy and you hear about UV radiation, it's not all UV radiation, it's going to be certain forms of it. So we then again, we do associate some of the sun's energy to be potentially causing some skin problems. Now, before we go any further, we should also understand that when we tan, for those of us who are pale enough to tan and get darker, when we do tan, that actually is a natural response. By producing more melanin, by protecting our nuclei from more damage, it's a natural response, a natural protective response. The damage is how much radiation we're getting and for how long, because the longer we get it and the more intense the radiation, the greater the risk of developing skin-related problems associated with this radiation. So why? Why does UV cause a problem? And again, we're talking about UV in the overall perspective here. They're trying to show you in this chart a couple of different things related to UV damage, but we'll kind of simplify it for our understanding here. Notice they're showing the energy coming in from the sun, and this trans UCA to cis UCA, all that is basically is a specific kind of damage we associate with UV radiation, and they're showing over here more generally DNA damage. What you get from this particular side of the fence is immune system depression. So things like Langerhans cells that we talked about before that help defend us against microbes, they're not going to work. There may be some local and systemic responses that are affected, local damage to the skin, for example, that you don't heal. You also can get DNA damage, which can do the same thing, but it can also result in genetic mutations, including in particular what's called tumor suppression and activation. Fancy way of saying we have a gene, a series of genes, but one in particular called P53. P53 helps us recognize when our cells are damaged, stops our cells from dividing, and triggers a process of either cell repair or cell apoptosis, damage. So if UV damage occurs to where the DNA is damaged and we get mutations and we have immune system suppression, we're going to have abnormal cells, and therefore, it's kind of hard to see at the bottom of the screen here, we're going to have, let me get this so you can see it, we have the production of, tumorigenesis is the production of tumors. Now, in a healthy skin, we're going to have perhaps cell cycle arrest. That is, if the sun does damage some cells, the cell cycle will stop. There will be no more mitosis until we fix the DNA damage or we carry out apoptosis, cell suicide, and therefore all we have are normal cells. So the short answer to all this is that UVA, or sorry, UV itself, UV radiation, either damages our immune system responses or our DNA responses. So ultimately, damaged cells do not get fixed and they proliferate. So we can observe different kinds of photo damage when we look at the effects of this radiation on our skin. We can talk about first, second, and third degree burns that we associate with tanning per se. We also can look at, if you use special kinds of visioning, you can actually notice, for example, damage to the skin that you really can't observe. Oops, let me fix some stuff here. That you can't observe unless you have special radiation. For example, all these dots here are indicating of skin damage from radiation exposure. We also notice here wrinkling. We didn't get into this in too much depth, but certain kinds of radiation actually can damage collagen fibers, and collagen fibers and elastin fibers in the dermis are responsible for our skin's viability. Damage to those fibers does result in wrinkling. So photo damage can be related to DNA damage leading to cancer, or it can also damage the underlying tissues underneath the basal cells that can result in damage we associate with wrinkling. I gave you this chart here to look at because one of the common places that we associate with damage and cancer are with moles. Moles can become cancerous in certain cases, and that's why it's very important to pay attention to moles, especially as moles change, because as moles change, they could actually be indications of cancer. For example, the warning signs to look for are the A, B, C, D, E. Moles that are asymmetric. Moles should be round, and when moles take on an asymmetric look to it, that could be a mole that's actually undergoing irregular cell division. Border irregularity. The border actually has, it's not round, it actually has projections or juts. That suggests that that's probably an irregular mole. Color. Moles should be of one color. When moles have multiple colors, as you see here, there's some tannish and blackish areas, and even some whitish areas. That suggests a potential mole to have checked. Diameter. Moles should be small, a 1/4 inch or about 6 millimeters. When moles are bigger than that, that might mean that a mole is progressing through some irregular cell division and could be a potential form of melanoma. And the last one, and I don't have a slide of this, is E for elevation. If moles if you look at it from the side and they're jutty, then that's actually a bad sign. Moles should be more or less smooth across the top. They should not have irregularities. They should be more or less the same all the way across. So when we talk about the kinds of skin cancer, the skin cancer actually is the most common kind. Nearly half of the cancers in the United States, for example, are skin cancer. And they come in two basic types, non-melanoma and melanoma. Non-melanoma refers to two kinds of cancer. Let me type these up for you here. There's one kind called basal cell carcinoma, and another kind, I can't get rid of this, sorry, and a squamous cell carcinoma. These are the two kinds of, oh, come on. Okay, getting rid of it. Okay, so these are two kinds of, sorry, it's almost just off the side of the screen, but two kinds of non-melanoma. So these will start obviously at either the basal cells. The basal cells are the cells of the stratum basale, or some squamous cells. These are obviously going to be in sun-exposed areas of the body, and these are rarely going to spread. While these might make up quite a few of our cancer cases, they really result in about less than 1% of cancer deaths. So they're more than 99% curable. There's some pretty obvious signs when you, and we'll spend time on this video looking at them, but a crusty area or an area that doesn't heal in the body often may be at one of these non-melanoma forms of cancer. So again, they're not very lethal. They're pretty easy to treat. They're obviously, well, you can see them, and they're probably going to be in sun-exposed areas. A very common area is on the nose because it gets a lot of sunlight. The other form of cancer, though, is called melanoma, and this will obviously begin in the melanocytes. And it's a small percent of the cases, only about a quarter of the cases of skin cancer are melanoma, but it's more dangerous. That the problem with melanoma is it's going to be more likely to metastasize. And because it will metastasize and spread, it's going to have a higher lethality rate. Roughly a quarter of the melanoma cases are going to be fatal. So it's less common, but more fatal. Non-melanoma is more common, but less fatal. So what are some of the risk factors we associate with skin cancer? Obviously, the biggest one we'll focus on is going to be unprotected and or extreme exposure to UV radiation. Sunlight, obviously, because of its radiation forms, is going to be a large risk factor. We get most of our radiation in our lives before the age of 18. Because we're outside playing and we're not inside working. So a lot of our sun exposure occurs in kids. Other risk factors include having a pale complexion. If you are pale complected, if you don't produce as much melanin as other people, then obviously more radiation is getting to your nuclei and of your basal cells, and therefore increasing your risk of cancer. A family history might be partly because of a paler complexion, but also because you may have genes that heighten your risk for this. If you've had severe sunburns in the past, that might be, you might have done some damage to some cells way back because of a severe sunburn. Like if you had a bad second-degree burn where it blistered, you may have really damaged some cells that, because they're very slow growing, may not show up as a cancer for many years later. And there's some other risk factors as well. Even things like smoking, increases the rate of skin cancer. HPV, the human papillomavirus that we associate really with STDs, but it does increase the risk of skin cancer. And those who are on immunosuppressive therapy have a higher risk because they are kind of depressing their immune system, and perhaps cells that are cancerous that would have been detected and destroyed by the immune system are not being detected and destroyed, and therefore remains a risk factor. There are some people who go, well, that's okay. I'll go to my dermatologist, and my dermatologist will make sure I don't have any skin cancer. I just showed you this stat, not to beat up dermatologists, but to show you that even melanoma, a deadly form of skin cancer, dermatologists about a quarter of the time didn't recognize it as skin cancer. And non-dermatologists, like a general practitioner, fared even worse. The only way you can really tell is to do a biopsy. So if a dermatologist or non-dermatologist looks at a potentially cancerous mole and goes, I think it's okay, and doesn't get a biopsy, then you may not know that it actually is melanoma until it spreads into the underlying tissues and takes off. So not all pathology reports, even when you get the biopsy done, are correct. So even then, there's still a slight chance, not trying to depress you, but even if you get the diagnosis, it may be incorrect. So if you're not sure or have suspicions, then it's always a good advice to get a second opinion. So what about tanning beds? Again, people ask about tanning beds because they may think that tanning beds are going to be a much better option. They're not going to have any risk for cancer. And the actual answer to that question is, well, this. Dermatologists do not think there is a safe level of exposure to tanning beds because tanning beds, while they may alter the UV spectrum a little bit, are the only way that you start to tan is to have UV stimulation of your melanocytes to produce melanin to cause you to tan. Any stimulation of these melanocytes is going to obviously increase, that radiation is going to be an increased risk for developing cancer. The stat I have here is there's a 75% greater risk of developing melanoma if you are using a tanning bed. You also have an increased risk of developing non-melanoma forms of skin cancer. So we really don't think there is a safe level of exposure in tanning beds that is going to be a lot safer. Probably there's some level of tanning bed exposure that can be very safe, but that might not be enough to give you the tan that you really want. There are some places, including North Carolina, and many countries that are either looking to or have already banned the use of tanning beds by those under the age of 18 unless it's for medical purposes. Just because, again, if you have somebody who starts off their life at 13, 14, 15, 16, getting a lot of exposure from UV radiation from tanning beds, then they're going to definitely increase their lifetime risk of developing cancer down the road. Okay, we will focus on some other pathologies in a coming video.